In this video, I'll be solving the fifth problem of JEE Advanced 2025 paper 1. So we were given two planes, two planes, and their line of intersection is L1. And we were given another line L2 which is passing through a point in parallel to line L1. And we were given a plane, and that plane is meeting this L2 at a point Q, and R is a foot of perpendicular from point P onto this plane M. So there is a lot to do in this question. So first, like if we consider the plane 1. So the plane 1 they have given us 2x plus 3y plus z is equals to 4. And plane 2 is x plus 2y plus z is equals to 5. So whenever two planes are intersecting, so we'll have a line of intersection among two planes. So if we solve, like if we subtract these two equations, these two plane equations, if we subtract, we will get x plus y is equals to minus 1. And if I multiply by 2 and subtract the same equations, suppose like the second equation, if I am multiplying by 2, so 2x plus 4y plus 2z is 10. And if I subtract that from the first equation, so I'll be getting y plus z is equals to 6. So by solving these two, we are getting x plus y is minus 1 and y plus z is 6. So that implies x plus y is minus y and z minus 6 is minus y. So that means x plus 1 by 1 is equals to y by minus 1 is equals to z minus 6 by 1. So that means the line L1, which is intersection of these two planes P1 and P2, is nothing but x plus 1 by 1 is equals to y by minus 1 is equals to z minus 6 by 1. So that's the line L1. Now line L2 is passing through point P 2 minus 1 comma 3 and it is parallel to L1. So that means the directional ratios will be the same, will be just 1 minus 1 and 1. So L2 is passing through the point 2 minus 1 and 3. So that means L2 will just be x minus 2 by 1, which is equals to y plus 1 by minus 1, which is equals to z minus 3 by 1. Since it is passing through minus 2, 1 comma 3, so it is x minus 2 by, and the directional ratios are 1 minus 1 and 1. So L2 will be x minus 2 by 1 is equals to y plus 1 by minus 1 is equals to z minus 3 by 1. So we found like what is L1 and what is L2. So now like this line L2 meets plane M at point Q. So plane M is 2x plus, so let's denote M. So M is 2x. So the plane M is 2x plus y minus 2z is 6. So now they have given that line L2 meets plane M at Q. So that means this L2, so if we consider any general point on L2, so that will be some 2 plus k, comma, so basically what am I doing is I am just like considering that it has some k. So x will just be 2 plus k, y will be minus 1 minus k, and z will be 3 plus k. So now like this point, so this L2 line is meeting M at point Q. So if we solve like 2 times 2 plus k, if we solve this particular line L2 with this M, we'll get point Q. So that means like 2 times 2 plus k plus minus 1 minus k minus 2 times 3 plus k is equals to 6. So that means 4 plus k, 4 plus 2k. 4 plus 2k minus 1 minus k minus 6 minus 2k is 6. That means 3 minus k minus 6 is equals to 6. That means k is nothing but minus 9. So when we substitute this k value in this x, so x is 2 plus k, y is minus 1 minus k, and z is 3 plus k. So if we substitute, so our point Q will just be minus 7 comma 8 comma minus 6. So that's point Q. Now like R is foot of perpendicular drawn from point P onto plane M. So we know the equation of the plane M. So basically we are having a plane like this. So the plane equation is 2x plus y minus 2z is 6. And we also know what is point P. So what is point P? Point P is nothing but 2, minus 1 and 3. So point P is some 2, minus 1 and 3. And so there is some point on, so this line L2 is meeting at this point Q, which is minus 7, 8, minus 6. And then, so we were given that R is foot of perpendicular from P onto plane M. So that means R is a point on this plane which is at perpendicular to this QR. Now like we can find like what is PR, because like PR is acting as normal to this plane. So that means directional cosines or directional ratios of this PR will be same as the normal vector of the plane 2x plus y minus 2z is equal to 6. Now the normal vector of 2x plus y minus 2z is equal to 6 plane is 2i cap plus j cap minus 2k cap. So that means the directional ratios of this PR will just be 2, 1 and minus 2. And we already know that PR is passing through this point P. So I can write PR line is nothing but x minus 2 by 2 is equals to y plus 1 by 1 is equals to z minus 3 by minus 2. So this 2, 1, minus 2 are nothing but the coefficients of x, y, z in this plane, 2x plus y minus 2z is equal to 6, because that is the plane equation, and normal will be just perpendicular to this plane, and we can see like PR is acting as a normal here. Now R is on this plane 2x plus y minus 2z is equal to 6. So that means if we equate it to some t, so what is x? So x is some 2 plus 2t, and y is minus 1 plus t, and z is 3 minus 2t. So this is like any point on this particular line PR. So any parametric point, so a parametric point on this PR is this particular thing. So now like if I substitute this thing into this, I'll be getting the R value, because R is a line which is on the plane as well as on the line PR. So that's why like by solving these two equations we'll get like the value of R. So what will be the values of t? So 2 times 2 plus t plus minus 1 plus t minus 2 times 3 minus 2t is equals to 6. So that implies 4 plus 4t minus 1 plus t minus 6 plus 4t is equals to 6. So that means 9t minus 3 is equals to 6. That means 9t is equals to 9. And that means t is equals to 1. Now if t is equals to 1, that means x is nothing but 4, y is nothing but 0, and z is nothing but 1. So the point R is nothing but 4, 0 and 1. So if we consider the 2D view of the same thing, so we are having R, PR as perpendicular onto the plane, and P is any point in the space above the plane, and Q is another point on the plane. So we got the point like Q minus 7, 8 and minus 6, and R is, we just solved, like it is 4, 0 and 1, and P is given in the question that it is 2, minus 1 and 3. So from this, so if we consider the option, so we need to find what is PQ, QR, and we also need to find the angle. So let me just take these options so that we can use it over here. So if we consider the options, we're having PQ. So PQ, if we find, that is nothing but square root of 9 square plus 9 square plus 9 square, which is 9 root 3. So that means option 1 is correct. Now QR, if we find, that is 11 square plus 8 square plus 7 square, which is square root of 121 plus 64 plus 49, which is square root of 185 plus 49, which is nothing but square root of 234. And PR is nothing but square root of 2 square plus 1 square plus 2 square, and that is nothing but 9, which is square root of 3. Square root of 9, which is 3. So this is 3, and QR we are getting it as 234, so that means this is wrong, square root of 234. And PQ is 9 root 3. So that means like area, so area of PQR, if we have to find area of PQR, so that is nothing but half times 3 times square root of 234, that means 3 root 2, 3 by root 2 into root 3, 234, which is correct. And the acute angle between PQ and PR, so PQ and PR, if you consider it as theta, so cos theta will be 3 by square root of 234. So that means this thing is wrong. Oh, sorry, like cos theta is 3 by 9 root 3. Sorry. So even then, like this option is not correct. Like, so the correct option will be A and C. So that's it for this video. We'll meet in the next video.